questions? All righty, good morning, everybody. Let's get started. Let's continue with climate change. Before I do, a couple of quick comments. As you all know, the grades have been posted for exam number 2. Several of you have reached out to me, and I appreciate that. I encourage you to continue to do that, right? Please don't stay in a vacuum or a bubble if you don't feel like you're getting the help or you don't feel like you're getting the feedback that you need. I'm happy to look at the final third of the material. I'm happy to look at scenarios, talk about whatever you need to in terms of how to improve moving towards the third exam. Anybody got any logistical questions or any exam questions that I can address before we get started? Is everybody good?
Oh, I have a question, Dr. Slattery.
Yeah.
I wasn't able to see what questions I got wrong. Is that like still a thing, or are we just not able to look back?
It's my thing.
Okay.
Yeah, it's a thing.
I remember you said that. I'm so sorry.
Yeah. No worries. But I'm happy to meet with you, Holly, or anybody on Zoom, and I've done that already, and go through the questions and see what you got wrong for sure. Yeah, it just doesn't put it out there for permanent access.
That makes so much sense. Thank you.
Good. Any other questions before we get going? Okay, so we have 2 more sections here on climate change and global warming, right? And so we've talked about the composition of the atmosphere. We've looked at how these different gases in the atmosphere interact with energy from the sun and interact with energy from the earth. So here's the summary diagram then, the follow-on diagram from the electromagnetic spectrum. And this diagram really summarizes the greenhouse effect, right? Explains the greenhouse effect. So the way in which I've tried to show this in this diagram is we've got incoming solar radiation from the sun, okay? And so let's just use it as percentages. So let's say we have 100 units or 100% of the energy coming in from the sun, right? Only about half of that energy actually makes it to the Earth's surface, right? and ends up heating the Earth's surface, whether it be land surfaces or ocean surfaces. So what happens to that other 49%? Well, some of it is absorbed in the atmosphere, we know that, right? The gases get it, and in particular gases like stratospheric ozone will take some of that energy out. And some of that energy from the sun is just simply reflected off the top of the clouds or reflected off surfaces off the Earth, especially things like snow caps, right? So that's the first part of the greenhouse effect. Is that roughly about half the energy that comes to us from the sun is actually used to heat the surface of the Earth. Then what happens? Well, the Earth heats up. It becomes this emitter of energy, right? And that energy is then emitted back to outer space. Some of that escapes directly to outer space through the atmospheric window, right? Remember that section that's shaded underneath the curve. But this is by far and away the most important aspect of all of this, right? And that is that as the Earth begins to emit energy back to the atmosphere, those gases in the atmosphere like water vapor and methane and carbon dioxide absorb that energy, and therefore they warm up the atmosphere, and the atmosphere then begins to emit energy back towards the surface of the Earth. It doesn't act like a blanket, right? Those gases don't trap the energy, so to speak. I know a lot of people think of it as a shield or a trap. It's not. Those gases absorb energy. And if anything absorbs energy, it becomes an emitter of radiation. Right? So the bottom line to all of this, everyone, if we want to think of a way of summarizing the greenhouse effect, is that we get our heat energy from two sources, okay? This is one of them. Certainly the sun is important, right? If it wasn't for the sun, we wouldn't be here. So we get our energy, our heat energy that keeps our planet livable from the sun. But by far the more important source of our energy in terms of keeping life here on this planet is this part, is the greenhouse effect, right? The energy that we get from the atmosphere that is emitted back towards the surface of the Earth. Remember, if we didn't have the atmosphere around our planet, our global temperature on average would be minus 18 degrees Celsius, and we wouldn't be here. There would be no worries about exam number 3 or anything, okay? So this greenhouse effect is what keeps this planet livable. Does that make sense to everybody? Everybody happy with that? Okay, here's a summary. Here's another way to look at it. And then we'll get on to the second part of climate change. This shows two planets, right? Here's Venus on the left, which is closer to the sun than Earth, right? And Venus on the left, this shows the impact of how thick the atmosphere is and what the gases in the atmosphere are. So Venus is closer to the sun. So this is the amount of radiation that strikes the top of the Venusian atmosphere, right? About 645 watts of energy for every square meter of the top of the Venusian atmosphere. You don't have to remember that number. That's not critically important. What is important is when you look at Earth, which is further away from the sun, it gets about half the amount of energy going into the top of the atmosphere, right? But here's the problem. A whole bunch of that energy that strikes the top of the Venusian atmosphere is reflected off the top of that atmosphere because the Venusian atmosphere is so dense. It's about 5 times thicker than the Earth's atmosphere, right? So one, it's much more dense. And so not much energy can get through the atmosphere, right? So when you look at the Venusian atmosphere at the surface of Venus, 130 watts of energy is absorbed, whereas at the surface of the Earth, about 240 watts of energy absorbed. In other words, the Earth gets about twice as much energy at the surface, and yet look at the temperature on Venus, right? The temperature on Venus at the surface is about 460 degrees Celsius. That's pretty toasty, right? 460 degrees Celsius. Okay? Nothing can live there, right? It's a burning mess. Whereas our average temperature at the surface of the Earth is a nice balmy 15 degrees Celsius, or about 64 Fahrenheit. Why? Because of the greenhouse effect. In Venus, they have a runaway greenhouse effect. Look at the bottom here. 96% of the Venusian atmosphere is made up of carbon dioxide, right? That selective gas in the atmosphere of Venus keeps almost all of that energy stored within the atmosphere, and it's just overwhelmingly hot, right? So that's another way to understand that the temperature at the surface of the various planets in our solar system is governed by the nature of the atmosphere. Yeah, it's important, like Venus is closer to the sun. Okay, we get that. But that doesn't account for the runaway temperature. And you may hear that term, right? The runaway greenhouse effect. So I thought that would be a good spot to just stop, see if there are questions, and then redirect now towards a different aspect. Everybody happy with that, right? The greenhouse effect. So bottom line, The greenhouse effect is a naturally occurring process that keeps our planet livable. All right, cool. So that's a little bit about how the atmosphere works. Okay, now let's move on. Let's get to climate change and global warming, right? So here's what I want to do, everybody. I want to spend the rest of the morning talking about a little bit about the politics of climate change and global warming. I'm not scared at all about shying away from those. I want to talk about kind of the framing and the context in which this issue is discussed. And then we'll get to the carbon cycle and then the nuts and bolts of temperature and carbon, okay? I do want to say, everybody, I'll preface this by saying I've been very impressed with this class, in all honesty, about the way in which you've conducted yourself online and the way in which you've engaged in discussion and questions. I've been really impressed with the civility of all of that. Not that I expected anything less from Horned Frogs, but I've just been impressed. And I say that here because there's topics here where I'm going to give you what the research says, and then I'm going to give you my opinion. And you absolutely don't have to agree with my opinion, right? Because this subject of climate change and global warming, I don't know how you folks feel, but this is, well, no pun intended, this is a hot topic, right? This is a conversation piece. And in the environment that we live, and this is my opinion, the environment that we currently live in, this polarized environment, politically, geopolitically, this is an environmental issue, and this is the environmental issue, I think, that polarizes people very quickly, right? Like at Thanksgiving, if you really want to have an interesting Thanksgiving, talk about politics at the Thanksgiving table. That'll get people going, right? Sorry, that jumped forward. And it's the same about climate change and global warming. And I get asked it all the time. So I'm going to navigate this openly, transparently, honestly, and I'll tell you, here's the research, here's what the science says, and here's just simply my opinion. Okay. And I'd be happy and grateful if you chimed in as well and say, you know what, Mike, I disagree, and here's why. Okay, so let's go through this. So these images here, if you do a Google search, these are not necessarily the first 3 images that come up, but if you do a Google search on global warming, right, and climate change, those 2 terms, and I've made the point that global warming, remember, refers specifically to the acceleration of global temperatures, the warming of the planet, driven largely by humans. That's how the scientific community discusses it. Climate change is a broader topic that looks at changes in habitat and species and temperatures and precipitation and so on. But these are the images that you'll see, right? You'll invariably see polar bears clinging to ice caps, right? They've become in some ways the kind of, I don't know, poster child for climate change or global warming. You'll certainly see images of pollution spilling out into the atmosphere. And invariably you'll see images of destruction and hurricanes and storm damage, flooding, and so on, right? And I think that it's a bit of a shame, to be honest, my opinion, that the discussion of climate change and global warming, and let's just lump those 2 terms together for the moment, that being able to discuss this issue of climate change and global warming, I think, is difficult in today's environment because it as an issue is portrayed in the media in ever increasing apocalyptic terms, right? And I don't know if you folks agree with that or not, right? But we see these dramatic images of the ice caps are melting, the polar bears are dying, the sea levels are rising, and our society is all going to go belly up, right? Now, whether that's true or not, let's just set aside for the moment, right? But I think there is this kind of dramatic, I refer to it as meteorology, not meteorology like with a T that talks about, a meteorologist on TV talking about the weather, but meteorology with a D, the media and the discussion of climate change in the media, right? And you folks know, if you can choose a particular news station on TV and you'll get a different view of climate change depending on what station you put on, okay? So that's the first part, I think. I just want to get out there that we've got this very complex scientific issue of global warming and climate change. And that is being portrayed in the media and described by the media and discussed within that space I think, in a fairly polluted scientific communication environment, right? I don't know if you agree with that, but that's my sense of it, right? That if someone asks me, and I get asked this question all the time, and you may be in the same boat as me, everyone, I get asked this question, hey, Mike, do you believe in global warming, right? I mean, I get that asked all the time. And, you know, as old and gray as I am, I should have this like really quick 30-second elevator pitch answer that says to someone, well, of course I believe in global warming. I mean, you know, I have a PhD and I'm a climate scientist and I published papers. And that's like really disingenuous. And someone may be asking, hey, dude, chill. I'm just interested to find out if you really think global warming is real or not, right? And it's like, I don't know, I always have to check myself, right? Okay, so this person is asking if I believe in global warming. If I said yes, I'm probably going to be put into one pigeonhole very quickly. If I said no, I'm going to be put into another box very quickly, right? You see where I'm coming from? It's and we don't have the space. It's like I don't have the time, and this person probably doesn't have the time to sit down in Starbucks and get a lecture on global warming and greenhouse gases and me to pull out the electromagnetic spectrum. I mean, they would be like, you know, I'm out of here, right? So it's a really, really complicated topic. And I always find myself kind of struggling, to be honest. At the end of all of this, when we finish this chapter, I'm going to give you my 30-second elevator pitch. I won't give it to you now, but I'll give you my 30-second elevator. And we'll see what you think. Just some other comments, and then I want to get some feedback from you. These are old issues. These are mid to late 2000s. These are the first two green issues of Vanity Fair. The left one is the first green issue, right? So just look at the verbiage here, okay? This is a new American Revolution, right? Global warming is a threat graver than terrorism. What do you guys think when you see that? Besides the 4 eco warriors all dressed in green fighting for the planet.
I just think that like it's a triggering word, you know, so it makes people kind of, I mean, it incites fear in people.
Okay, good. I agree. So there's a fear issue here, right? How much of New York, Washington, and other American cities will be underwater? Look at the question under there, right? It's like, hey, we should be buying property in DFW because give us a few years and we'll have beachfront property, right? It's like, not sure about that. Other thoughts, comments?
I think it's interesting how they chose these celebrities. Like, are they even doing anything in their daily lives to be more eco-conscious themselves?
Right. So there's Al Gore, right, the former vice president, and I'll talk about him in just a second. There's RFK Jr., an eco warrior. There's George. I do like George. I mean, what a handsome devil. That's just chronically unfair. But he's like a big eco dude, right? And there's Julia Roberts, right, in her green outfit. And of course, you look at the right here, here's Leo, like him as an actor, and actually has done some really good work, right? But he's a climate advocate, okay? And I don't know how that resonates with each of you, right? You may go, hey, I like Leo DiCaprio and I believe in what he says, or you may think, really? I mean, Leo, how much science have you really done in global climate change? So Chineri, your point is well taken. Why these and these celebrities, they have a platform, right? They do have a platform. And of course, look at the baby polar bear looking up at Leo going, hey, please save me, you know, from this, you know, threat graver than terrorism. So Colin, your comment in the chat is well taken, right? Since the early 2000s, people might relate to the attack of 9/11 to this. Yeah, is it, you know, where does other threats, can we really kind of have a threat scale and say terrorism is down here and then up here at the other end of the scale is climate change, right? It's problematic for sure. Again, I've chosen these specifically for a couple of reasons. These are mid-2000s reports from Time magazine. Just look at the verbiage, everybody. The Global Warming Survival Guide, right? 5 things you can do to make a difference. I get that asked all the time, right? What can I do? You know, if someone says to me, listen, I think global warming is real and I think humans are driving it. So what can I do, right? And, you know, it's like, well, okay, gosh, buy an electric vehicle. And they go, well, I can't afford a Tesla. Okay, you know, and you start struggling about what are the little things that an individual person can do relative to, to industry. On the right, don't be worried, be very worried, right? the Earth is at a tipping point. So my point here is that this is the kind of language that we see in global warming. I'm just going to look at Holly's comment here. I kind of cringe when I see celebrities who have giant homes and take private jets and tell me how to be a better individual when it comes to climate. Okay, so here's the next one that speaks directly to that, right? So if you are a global warming proponent, in other words, if you think climate change, global warming is real, and you think that humans are driving it, then this might be a person that you turn to, right, for your science or to be as a spokesperson. So the former vice president, a very strong advocate for policy to combat greenhouse gases and for global warming and climate change. And of course, he did the documentary in Inconvenient Truth, right? I don't know how many of you saw an Inconvenient Truth, won Academy Award. And Holly, to your point, Al Gore, flying around the world in his private jet with his gigantic carbon footprint, lecturing, the world on global warming and climate change. There was a funny cartoon in the New Yorker, I should have put it up, of two Eskimos in an igloo, right? And they're sitting in the Arctic. And there's Al Gore walking towards them with a whiteboard and an easel with his private jet in the background. And the one Eskimo says, "Oh no, here comes Al Gore again to lecture about global warming," right? And so, so there's that aspect, right? If you're a climate or global warming skeptic, okay, and or denier, and let's just talk about those two terms, then the 45th president might be your spokesperson, right? President Trump was and this is my opinion, was kind of all over the place when it came to global warming and climate change, right? He would tweet a lot about climate change and say, hey, this is it. Before he was president, he put out the tweet that it was a Chinese hoax to impact the American economy. But there are equally quotes where he said, yeah, I think global climate change is kind of real and we need to do something about it, right? So my point here is not to endorse or not endorse either of these political figures. But that's why I think the science communication environment is problematic, okay? And if you're interested in this topic, and I want to just get to a quick poll in a second. If you're interested in this topic, everybody, there's a person at Yale called Dan Cahan, and I'll put it in an email to you. This is not my quote. This is his quote. Dan Cahan at Yale has done some really interesting work on people's perceptions of global warming and climate change, right? And Dan writes that people endorse whichever position reinforces their connection to others with whom they share important commitments, right? And so I guess what he's trying to say is it comes down to your group or your people or your tribe, right? If you are of a certain political sway, it may be very, very risky for you to step outside of that and you say, you know what? I think global warming is real and humans are to blame. Because if the rest of your group don't share that view, then you will be seen as one of them, right? And vice versa. Do you see where I'm coming from this? So it's difficult, right? It's complicated, okay? When we look at some interesting research, let me go through this research. I see there's a couple of chats there, which I'll get to in a second. But this is some research that was done in 2019, November 2019. So it's fairly recent, right? By the Pew Center. So pretty reputable, very reputable nonprofit. And this is a research of several thousand US adults. Again, this is not my opinion. This is the result of this research, right? So one of the questions here from the survey was, what % of US adults think the federal government is doing too little to reduce the effects of climate change? So of the respondents, again, about 4,500, 90%, so the numbers are rounded up here, 90% of the respondents that identified themselves as Democrat or leaning Democrat said, yep, I think the government is doing too little, right? And when you look at the respondents who identified themselves as Republican or leaning Republican, 40% said they thought that the government was doing too little, okay? But when you actually, not me, but when the Pew Center broke those responses down under the Republican-leaning Republican, right? Look at how those percentages changed to the Republicans who identified themselves as moderate or liberal, right? So here's my opinion. And it's not an opinion, it's my experience, but this notion that all Democrats are pro-environment and believe in climate change and all Republicans are anti-environment and believe that it's a hoax is just simply not true, right? It is not true. Is there a political bias? I think there is. That's what the data shows. But I, for one, am getting pretty tired of everybody being forced into one or two boxes based on your political affiliation. So I know this is a touchy subject, but let's talk about this for a minute, and then I'm going to ask you to respond to it. So thoughts? From Holly, yeah, I totally agree. I wish that more politicians had a background in general science studies to understand the research that's being, yep, I agree with that. And that's an interesting comment, Neela. Anybody got any other thoughts of this before I reveal the other part of this?
It kind of seems like the younger generations are a little more like agree that the government's not doing enough.
Right. Yeah. So there's an age. I don't know. What am I? I'm not a millennial. I think I'm right on that. I think I'm right on that border of Boomer Gen X. Isn't 1963 or 1974? Something like that, right? But yeah, there is an age. There is an age bias and there is a gender bias, right? At least that's what the data shows. Okay, when you look at this is another interesting one. Just reveal this. It shows the percent of US adults who say that human activity contributes to global climate change, right? So just let's get to the global climate change part. So this is quite interesting, right? If you look at a great deal or some, okay, you know, almost 80% of US adults believe that we play some role or a large role in impacting climate. Okay, and then look at the political breakout. I think this is really, really interesting. Those who identified themselves as moderate or liberal Republicans, right? I mean, that's way up there, almost 80%. Okay, so again, I'm not trying to argue pro-Democrat, pro-Republican, anti-Democrat, anti-Republican. I just think that the science communication environment that we live in, which has become polluted, if we cut away all that spin, my sense is that the vast majority of people all want the same thing, right? They want a clean, healthy environment, a healthy functioning economy. It just seems very messy at the moment, right? Any other thoughts on that? Okay, let's do this quickly before we go on. Bottom right is a number. If you wouldn't mind just logging into Menti again, Mentimeter or Menti. Okay, I just want to take your pulse. Let's just see where you're at the moment. I'm going to stop the share and let me change the share here. So if you wouldn't mind going into that 3825-9315, 3825-9315. Did that change? Can you see the results there, everybody? Thanks, Cole. Appreciate it. So there's two questions here. Is the planet warming? 3825-9315. Let's see. Okay, we'll just let this populate for a second. Let me see I'll just go to the chat real quick. Thanks, Gabby. I should have put that in the chat. Appreciate that. Well, look at these eco greenies. Okay, strongly agree, maybe. Okay. Folks, I can't trace this back to who's answering what. There is no ramifications for being a climate skeptic. All right, so this is looking good. Populating. Right? Is the planet warming? Nope. Okay. 32. So 68, 70. All right. So that's up there in the 85%. Right? Is the planet warming? Cool. All right. Same poll. 3825-9315. To what extent does human activity contribute? To global warming? Interesting. Yeah. So I'm just going to make a note of these numbers because I want to refer back to the Pew poll. So 52 is a great deal, 16 and 2, not too much, not at all. All right, cool. Listen, thanks for doing that. I appreciate that. So let's just look. So 52. 53, 17, that's 70. Okay, I'll let it populate just a little bit more. So that's 70, 73. Let's just say that's 73 respondents, right? 3 divided by 70. Okay, that works. 75. Okay, there we go. Cool. That's 75%. Awesome. All right, so let me just go back to the screen share here. Okay, so here we are. We're back at the poll, and here is what the Pew response looks like, right? So here's the Pew response. So 80% of US adults felt that the climate, that humans were contributing, and you folks, 76% felt. Interesting, pretty good reflection, right? Now we haven't broken you out by conservative Republicans and liberal Democrats or anything like that, right? But my guess is that if we did this, I probably should do this, is that you would see something that is reflective of this, right? So thoughts, comments before we move on. I'm never shy about shying away from the politics of climate change, because it's a hugely political space to discuss it in. And I find myself trying to navigate this, and I've just decided I'm too old and crotchety to navigate it without just being honest about it, and here's what I think. So thoughts, comments?
I just wanted to add that I think that studies like these that do break people up by their political affiliations, whether it's just Democratic or Republican or anything in between, are contributors to the issue of political gridlock on climate change and on global warming, whatever you want to call it.
Totally agree.
Because yeah, it's all about partisanship at the end of the day. And like the polarization of our country is really what's slowing us down to me.
Totally
and I
agree.
think that it should just be like, what do you think? And it doesn't really have to come down to this.
You
Yeah,
see,
it's like,
yeah, sorry, go ahead, Holly. So I agree. Neela.
yeah, I have to agree too, because like I think that the division is slowing us down, and I wish that like we could just like together just see like the big picture instead of like making like, oh, I don't believe this as like a Republican view, or I do believe it as a Democratic view. Let's just look at the numbers and be like, this is something we should probably take a little bit seriously or not seriously. Like, let's look at the facts.
So how do we do that? Right? How do we break through and say, hey, let's science drive it?
I think I read this somewhere or heard it from somewhere that like, I think the reason why people are a little bit skeptical about climate change or skeptical about making new habits to fix climate change is because the solutions, like we don't know if the solutions that we have in place right now are going to fix the problems that we are having. Like, how do we know that, I don't know, recycling is really making a difference? And then I do think that there have been studies that come out that says, okay, at first we thought recycling was helping, but now there's problems with that system as well, or it's not producing the
right. They're just like
amount.
shipping to other countries.
Yeah. So like, how are we fixing the problems that we are trying to fix without creating more problems in the end?
So that's a really interesting point, and that's also part of the discourse on climate change, right? When we get to that point of, okay, let's say everybody agrees that we potentially have a problem here and we should probably do something about it, right? Then I think this sort of language, the verbiage, and Neela, your points, I completely take your point of fear, is that when most people, maybe I shouldn't say that, I think my experience is that a lot of people, when they get to that point, are like, okay, so this is going to dramatically impact my life, right? If I'm going to have to start making dramatic changes to keep global temperatures below 2 degrees Celsius, what is that going to mean for me, right? How's that going to impact my ability to drive a zippy little car, or take flights to go back to South Africa to visit my mom, or, like, are all the ramifications, do they all have to be negative? I don't believe that's to be true. I think that there is a lot of money to be made in the green, clean economy, right? Why should we be fearful of making these changes? And Chinera, to your point, which I think is well articulated and a good one, right? So if we're uncertain, what should we do? We can adopt the wait and see approach. And in 10 years, 20 years, 50 years time, when someone else is teaching this class, they go, you know what, folks, this is real. Like, we are now physically 3 degrees warmer, then it's probably too late. And if we make the changes now and it proves to be no big deal, then, you know, what's the worst we've done? Probably clean up the atmosphere of it. I don't know, it's tricky. A question from Holly, do you remember that campaign to cut the plastic can holders to help them save the turtles? Yeah, small and simple. Simple, absolutely, right? That, that campaign resonated with me because I bought some Sprite yesterday from Tom Thumb, and there I was, cutting up the little plastic things to make sure that they didn't go around the turtles. Any other thoughts before we move on, right? Cool. Okay, onwards. I think it's also, this is also on a similar theme. I think it's also quite perhaps easy to blame business, and in particular to blame big oil, right? And so, and I'm always wary of that, right? So people think, okay, it's all Exxon, Shell, BP, XTO, whatever the big energy company, right? They're to blame. Well, yeah, they're in the energy business, but I can tell you that there are very few, if any, that I can think of the big energy companies. I certainly don't think a CEO wakes up in the morning and says, all right, let's see how we can pollute the planet and really mess this up again today. And when you look at the chief executive of Royal Dutch Shell, I know this is a few years ago, 2014, they've made it unequivocally clear, as have BP, as have Exxon, right, that that they are not hiding behind this as some hoax, right? Climate change is real, and they know that it's a threat, and it's something that has to be taken seriously. Now, that doesn't mean to say that a company like Exxon wasn't funding skeptical research well into the 2000s. They were, right? But I think they've substantially changed their tune. And a large part of that is coming, I think, from the pressure from shareholders, right? Having a climate plan, a climate action plan, a carbon plan, having a corporate governance plan is no longer seen as just some fun thing to do. The shareholders demand it, and they're holding these CEOs' feet to the fire, right? Okay, questions. Let me see if I can go back to that. Yeah, so there's a couple of interesting points here from Kyle. There's also a conflict that comes into play when you look at funding for scientific research about climate change. This opens the door for lobbying and pushing agendas. Could not agree more, right? Kyle, that's an interesting comment. Science isn't done in a vacuum, right? We made this point, I think we talked about this when we talked about science and scientists early on, right? People look to the science community for objectivity, certainly creativity, but objectivity, right? But can scientists be bought? Yep, okay, absolutely, they can be, right? So you have to look at who's doing the science and where it's coming from, okay? So funding is a big issue, and the misappropriation of science for a particular lobby agenda, no doubt about it. Question from Nolan, do you believe it's more climate change or global warming? Global warming was pushed hard a few years ago, and it has shifted to more of a climate change topic. Okay, so that's an interesting comment, Nolan. So that's true, and I think part of it is that because when you say global warming, a lot of people get turned off. They're like, oh, okay, here we go again, you know. And some people use climate change to be a kind of gentler, softer face of global warming, but they really, and so I agree. I mean, I think it's both, right? I think if we are clear to say that climate change is a big, broad set of changes that includes precipitation, some places are getting warmer, some places are getting colder, some are getting wetter, some are getting drier, right? And there's places that will benefit from climate. Global warming is a different issue. Global warming is just the acceleration of temperature. So I think it's both, Nolan, to your question. Yeah, it comes back to politics. Nelly, I agree completely, right? Totally agree. Okay, good comments. I wish this course was 6 hours of credit, then we could double the time. Okay, so let's move on. So let's talk a bit about carbon. We've got 10 minutes. This was the, I apologize for putting this as a bullet point on the study guide. So this was the carbon cycle, which I inadvertently put on the study guide. So this next diagram will be on exam number 3. Take it to the bank, okay, in some form, right? I want you to understand the very basics of the carbon cycle, because this is the gas, this is the greenhouse gas that we're going to focus in over on the next lecture and a bit, right? Rightly or wrongly, it's not the only greenhouse gas. Water vapor is a critically important one. Methane is a critically important one. But we focus on carbon and carbon dioxide in particular. So here's CO2, the big carbon atom, and the two oxygens lumped onto the side, because this is the byproduct. This is the most ubiquitous byproduct of the combustion of fossil fuels, right? Carbon and CO2. All right, here's the lovely carbon cycle. And I don't want you to remember all the numbers here, but I do want you to understand what these numbers mean in context, okay? So, and just incidentally, everybody, this is what we call the short-term carbon, the short carbons. The long carbon cycle deals with carbon going into rocks over millions of years, right? This is the carbon cycle over human timescales, okay? Anything in blue is natural. Anything in red is anthropogenic or human, right? So here's the bottom line, right? And these numbers here, so the G refers to gigatons. So that's a gigaton, right? That's a billion tons, 1 billion tons of carbon. And this diagram refers just to carbon, C, okay? Everybody with me? Now there is a difference, and I don't want you to get confused on the numbers here, everybody, but let me point this out. It's really important. There's a difference in expressing carbon as C or CO2. And this little bit will be on exam number 3 as well, right? So let me explain this difference, and this difference relates to the numbers as to how it's portrayed, right? When you look at the periodic table, okay, the element carbon has an atomic mass, right? That number is 12. That's how heavy the atom is, right? So carbon has an atomic mass of 12. Does anybody know what the atomic mass of an oxygen atom is?
15.999.
There you go. 15.9997143 or whatever it is. You know what, Gavin? Let's just round that up to 16 if you're comfortable with that. Okay. So the atomic mass of oxygen is 16, right? There are oxygen atoms that are 17 and 18, but the vast majority, 99.9% of all the oxygen has an atomic mass of 16. Okay. So when we look at the atomic mass of carbon, it's 12. When we look at the atomic mass of CO2, it is 16 plus 16, right? Because there's 2 oxygens plus 12. Everybody see that? So the atomic mass of CO2 is 44, right? So carbon, when it's expressed as CO2, is heavier than carbon when it's expressed just as carbon. Does that make sense? And the way in which to change between the two is just to simply take 44 divided by 12. And that gives you 3.67. That's a number that's worth remembering. In other words, if you were expressing carbon, let's say as 1 billion tons of carbon or 1 gigaton of carbon, that is equivalent to saying 3.67 billion tons of CO2. And I just want to make that, I need to make that point because you're going to see diagrams that flip between the two, right? So this is the carbon cycle expressed as billion tons of C, of carbon, okay? So what are we looking at here, everybody? So what we're looking at is—
Wait, how does that work? Because that's tons and grams, right? And tons is pounds and grams is. So do we have to convert that all the way through and through, or?
No, just take it. It's just a ratio. So if you've got 1 gram of carbon, okay, that's 3.67 grams of carbon dioxide equivalent. Did that answer your question?
Yes.
Okay, thanks, Kevin.
Wait, so if it's 1 gigaton of carbon, that's 3.6 million grams of the CO2?
Yeah, don't mix up the grams and kilograms. Just keep them the same, right? So if you've got 1 gram of carbon, it's 3.67 grams of CO2. If you've got 1 ton of carbon, it's 3.67 tons of CO2, right? If you've got 1 trillion tons of carbon, you've got 3.67 trillion tons of CO2 equivalent. Does that make sense?
Yes, thank you.
Awesome. All right. So what's going on here? So carbon is continually cycled, right, between the atmosphere and organisms, vegetation, right, through photosynthesis, right? So, yeah, I probably should put capital G here. Any G here is a gigaton, right? So the bottom line is that there is a continual cycling of about 90 billion tons, 90 gigatons of carbon over the ocean surfaces, right? Plankton taking carbon out of the atmosphere, putting carbon back into the atmosphere. There is about 120 billion tons. I'm not going to ask you to remember these numbers of carbon that is taken out of the atmosphere by vegetation, right? Through photosynthesis. And equally, that 120 billion tons, the 60 on either side, goes back into the atmosphere through respiration, right? You and I breathing out, soil organisms all breathing out, okay? There's a continual natural cycling of carbon. A little bit goes into the atmosphere naturally through volcanoes, right? And then there's just this little extra 2 billion tons, right? So there's that 2 billion tons that is naturally being taken out of the atmosphere every year, right? Over the ocean surfaces. This is what gets important here. The stuff in red, right? That is the amount of carbon that is being added to the atmosphere by human activities. Does that make sense? About 9.5 billion tons goes into the atmosphere through the combustion of fossil fuels, right? About 9.5 billion tons. Folks, if you multiply that by 3.67, it comes to about 35 billion tons of CO2, right? And then we are adding, this is another big pathway here, we are adding carbon into the atmosphere through deforestation. When you cut down the trees, that carbon in the vegetation gets released back into the atmosphere, right? So humans are adding in total about 11.5 billion tons of carbon into the atmosphere, right? Both through the combustion of fossil fuels and through deforestation and respiration, over 40 billion tons of CO2. Of course, there's a bunch being taken out here, this extra 2 billion, right? Questions? This is the biggie. This is what we're going to focus on for the rest of the climate lectures, that 9.5 that are coming through the emission of fossil fuels. This we're going to come back and look at in chapter 7 with deforestation, right? So the bottom line, everybody, is that humans are adding carbon to the atmosphere, right? In the form of carbon dioxide through the combustion of fossil fuels. That's not up for debate. That's not some conspiracy theory. That's not some fake news. That's real. And it's real because we can observe it and we can measure it, right? That makes sense, the carbon cycle, okay? I've added this slide. I just added this morning just to make sure that I could remind myself, right? So this shows, this is the latest data. Okay, it's not in the book because it's 2020 data, but this shows carbon as carbon dioxide, right? And it shows carbon dioxide in the atmosphere from 1999 through to 2020. This is not absolutely confirmed, it's about an estimate. So what this shows is that CO2 is going up, right? It's going up, combustion of fossil fuels. Look at that, there's the financial crisis, right? 2008, it goes down a little bit, and it goes up a little bit, then it levels off a little bit, goes up a little bit, and here's COVID, right? It looks like the pandemic reduced CO2 emissions by about 7%, right? Something like 2.5 billion tons of CO2, right? Less than 1 billion tons of carbon. 2.4 divided by 3.67 is, whatever it is, a fraction, okay? And then we'll probably see after the pandemic, what will we likely see? Something like that, right? That makes sense? So again, I'm not advocating for pandemics as an environmental cleanup, but that's the reality of the lockdowns and the reduction of flights and the combustion of fossil fuels. So where we go from here, everybody, is, and again, so take this one to the bank, right? We are adding about 9.5 billion tons of carbon multiplied by 3.67, that ends up to be about 35 billion tons of CO2. And there it is, right? There's the 35 on the scale. There's the 35 billion tons of CO2 that we're adding through the combustion of fossil fuels, right? The question now that we have to look at is, what is carbon dioxide doing? What has it done historically? What is it likely to do? And the controversial one is, how is temperature going to respond, right? And perhaps even more controversial is, how is our ecosystem going to respond, okay? Because everything that we see currently in terms of climate change and global warming is predicated on this trend, and where this trend is going to go in the next 50 or so years, right? It would be great if we could do that. It's highly unlikely. So let me stop there. Thoughts, comments, questions? How are we doing on time? Ooh, we got a minute. All good. Okay. Awesome, everybody. Have a wonderful Easter break. We'll come back and we will wrap up climate change and global warming, and then we're going to march into our biological resources. We're going to talk about bugs and bunnies, trees and species and biodiversity. And we will tie that back to how climate change is impacting that. All right, I'll stop the recording. As always, I'm going to hang around a little bit. I'm happy to hang around and answer questions and whatever you need.
Thank you.
You bet, everybody.
Bye. Thank you very much.
Thank you.
Yeah, have a good one.
You.